Okay, so morning, Master Mason. No, what's up? So obviously, this is our stone mill again. This is Tompkins, all the guys in here, all the team. So I said something yesterday about spreading it around the room. You might get a cut coefficient, a thermal spot, something like that, but it doesn't quantify everything. It's just stone mill. So we bring stuff in. Obviously, that is what initially forms the inertia, the momenta, that block the this, that, or the other, which is something blue, brown, this, that, and the other. Kind of, this one's up on charm, making more money. Comparatively, this one's down, but on time, that's shiftable. That's something that you might mitigate outside that door in a little box. Just a little box here. Okay, same stuff. There's going to be an up-down spin charm on that same aspect there that has a given mass, that mg physics, like in that special relativity frame. And essentially, again, those are diamond tethers attached to every guy. I say when you're doing flipping treads or something like that, especially when you got like a stack behind it or something, it's a tug of war. Not necessarily for power in the company, but what physics is, because it's going to snap you. It's going to fucking nail you. So, like, what kind of parallels on all that curve or why general relativity curved universe? These are all flat lines. Like, this one's a grid in the standard model, this one's a grid in the standard model, and I computate those together in a brute force, a local code. This is all the letters and everything based on the universe, not gravity, not government, not anything like that. Here, this is the governing numbers. And then you get some numbers like OSHA or MSHA that stepped in. Basically limitations. It wasn't any of those things until it quantified into a stone mill for MSHA. But essentially, machines, OSHA, that's that subcategory. Pyramid of triangleability, because they both have a skid steer, people, machines, and servicing times, and so on and so forth, which are essentially loop gravity. Here it's be at the top that we took the time to take a mechanic and put them in here, because that is the form in time for the training in that school, or those choices, highly enriched material in those terms, that there would be some kind of charm +1. You ask any kid any question, 83 for the ASVAB here, just for psychology, those numbers are going to come off at a higher bracket. And then you bracket those numbers, you say next to this thing or next to this thing, it might have a positive or a 1 aspect. So a lot of times, again, like I said to Jordan Patterson in there, when he had his Acadesia episode, I would like to get those space-time generals in here as well. The loop gravity, string gravity, show me the adjustment, and then give me the X, Y's, and Z's on my time terms. Not only burning, there's getting them out of the saw. What's the setup up and down? And again, obviously this is civilian stuff. When you get into the governmental ideas where you get a lot of the team dynamics inside of here doing that kind of thing, you have to take extra special consideration on the salty variation on here. Essentially, all these numbers make drill sergeants, E7s from that E2. Master Mason, hopefully you guys can understand here. Comparatively to Veer, that in this shop would have a better mastery of it, but equally, my first step in the Fermilab is going to be, I'm going to hit some rocks. I'm going to have to hit some things to jump. So Mario, James, Stefan, Max, Matt, and Brian there, you're my Marios in this. Y'all going to perform right there to what the observation or rational number is. This is where this box, this marshmallow is. You can get roasted in here easily. You can use it for a psych experiment. You see that number right there, that X, Y, and Z? That's the determination on success. All that hard right here, you're going to save that for later, put it in your pocket, and that's a determination of success. Because margins off of that mg at the top in that form for right now calculate better physics than, well, I was a stone mason just throwing stuff up on the table until it was this high off of here and nothing could go. Like I said, this is a crash in solution. So here we see those equations. You got obviously right here's a wave function. And the fact timelines is this. If there's cracks and adjustments in there, well then these are going to mitigate that calculus on there, which I really don't need. I need the average of all those things across all the mill by days to tell me, you know, that really ranges all those negative ones in here to give them an extra half hour. That half hour is a particle. It's essentially the Higgs, the space in which all that energy for the proper collisions come off. Because this is going to come through here and it's going to have another Higgs collision here, except for here it's not strange matter. It's not inverting everything to calculus in a strange way. Here it's just action at that spooky distance. Here, math is that spooky distance relative to a stonemason mechanics in Fermilab or in the Hadron Collider, the railgun here. Comes in, particle comes through, we get it ramped up. That's stonemason stuff. It comes around here. There it's just one loop, just like this strange matter doesn't change this. It has an anti-particle effect. But to the proper release in physics where heat, light, and sound, any free radiance, energy, something is going to tone -1 to that calculus.